Hi everyone. So I thought I would finish up today's lecture with a few more examples of regular expressions. Let me remind you of the example we did in class. We had this language L that was all of the strings over the alphabet 0, 1 that started with 0, 1. And we saw that we could do this by matching 0, 1 and then any number of other characters. And if you remember, this is a common trick where this component is really just all binary strings. And in general, this kind of regular expression works whenever you have a condition that you want your strings to start with something. And if you flip this around, it's not too hard to see that if you want your strings to end with something, it's the exact same idea. So here we want all of the words over the alphabet ABC that end in BBC. So here's my BBC, and then anything can come before it, so that's A plus B plus C, star. So here's a slight variation, where now we're not talking about a string starting with something or a string ending with something, but really a string that contains something. Another way to phrase this restriction of having an A, or having at least one A, is that the string contains A as a substring. Oh, and of course here I really meant W has an A, and W has at least two A's. So how do we write a regular expression for this? Well, I know that I want to have at least one A, and as long as that A is matched, it doesn't matter what came before or what comes after. So this regular expression really matches any number of characters, then an A, and then, again, any number of characters. And notice for this regular expression, there could be A's in this part too. There's no reason why. That is, this regular expression also matches strings that contain, say, more than two A's. And not only that, this regular expression is ambiguous because it's not clear whether this A pattern is matching this A, or this one, or this one. But that's a little outside the scope of this course. You don't need to worry about making your regular expressions match strings in a unique way. That's not that big of a deal here. So let's move on to our next example. If W now has to have at least two A's, a natural way to go would be to say, okay, I want two A's, and then anything. But this turns out to be wrong. I'll let you think about why that is. Instead, I'll just say, whatever counterexample you came up with, it's solved by this case over here. And in fact, if you were being really clever, you could actually replace this with just B star. But again, that's something that I'll let you think about. And our last example. Here, there's a bit of notation, which I forgot to talk about in class. This really means the length of W. So L here is all binary strings with length at least 2. This one's a bit different because we're not talking about specifically what's in the string. We only want to match strings of a certain length. I want to match two characters. And then I don't care what happens next. This regular expression actually turns out to be equivalent to, I'm going to start with 0, 0, or 0, 1, or 1, 0, or 1, 1, and then follow that with absolutely anything. A more mathematically inclined student would notice that it looks kind of like we distributed in multiplication. This connection with arithmetic is something that I'll talk about a bit in my next video. And that's all the examples I have for today. Thanks for watching and have a great day.